Sui is a new layer 1 year old, and we like to say that we're building the building blocks of the new era. We have quite an ambitious goal of onboarding the next billion users on the blockchain. Here are some stats. Up until today, we have a very fast time to finality. We didn't have any attacks. We had a couple of unfortunate incidents where people just pressed accept and bad things happen because they didn't read what the attacker was saying. And the gas is very cheap. And I will explain why. So, a brief history. Everything started at Facebook or Meta. Facebook wanted to get into the blockchain business. They wanted to do a permission blockchain with for finance and for banks, and it was only about transactions with money. At first they needed Libra, then they needed DM, and they kept finding blockers with regulators, and they couldn't just go live for. So the team decided to break off of Facebook, and they created Sui, which is a permissionless blockchain, and they brought the idea to the world like this. So on Sui, things are going pretty well. DeFi is booming. We are getting up and up, and this is because we offer some unique features that allow DeFi protocols to do things that are not possible in general. Sui also is very bullish on gaming. We have a lot of gaming studios. These are the ones that I could fit in this slide, but we have many more. And we are expecting this year a lot of new game launches. We also have a device that is going to launch maybe next year. That year we'll be able to play these games from a console directly, and looking very forward to this. So Sui's vision is defined by our founder, Adeni, one of the 5 co-founders, is that we want to compete with the likes of AWS and GCP. I will always laugh when I hear that, but I'm starting to believe it. We have a new Mr. Labs, which is the company that first started Sui, has a new product that's called World Labs, which is a decentralized version of S3. So slowly we're getting there. And let's start with how Sui works. Sui is not a blockchain, it's a ledger, and the reason is that it doesn't have blocks. In traditional blockchains, you have blocks, and first you have to create the block, and then the nodes execute the transactions. But in Sui, we have transactions that don't go through consensus, so transactions are first executed, and then for ease of use, we have the thing that is called checkpoint, which is quite similar to block, but is done after the transaction can be executed. The general idea is we have 2 components. We call them validators. These are the nodes that are executing the transactions. And these are full nodes that are the ones talking to the validators. They are between the user and the validators. So they run the exact same code, but this part is allowed to execute transactions. These are only responsible for forwarding transactions for execution. So when a full node forwards a transaction, the validators decide if it's a valid one or not. If they execute it, they send back and say, we executed it. The full node also executes it in order for everyone to have the same state and reports the effects back to the user. So we have a controversy at Sui. We decided to keep the validator count, which are the blocks that are executing consensus and all the transactions, low. We have today around 100 validators, and Sui Foundation needs, so they need to KYC or KYB with the Sui Foundation. Also, the stake that they need is pretty large. Usually, they need a foundation scale. And the full nodes are, anyone can spin a full node. That is, so we call ourselves permissionless because anyone can do a full node, but the validator is a bit more involved. The reason why we chose that is a trade-off, but we wanted speed. We wanted the Sui to be really fast. And when you have a message that has to go through 20,000 or 30,000 nodes, there's no way today to make it go fast. So when you have a smaller number, then it goes a lot faster, and that's why time to finality. So this is the high overview of a transaction lifecycle. If you have bodies that owns an NFT, or because everything is an NFT, and I will explain this, why is that. Sui is an object-centric chain. We call ourselves object-centric because object-oriented was taken by Web 2. But the idea is pretty much similar. For Sui, everything is an object and it tracks the object and what happened to the end of the transaction. It doesn't track an address and what does the address owner does not know. So when you own an NFT, you tell the node I want to do something with it. It goes to the validator, and then the validator says it's okay, the transaction is okay, do what you wanted to do. In this example, Alice wants to transfer to Bob an NFT. And I will show soon how the state will change and how the state of Sui looks like. So a more visual representation of that is you have a smart contract. Smart contracts are stateless on Sui with Move, so they don't contain any state. They only have the definition of the assets that they produce and the functions that allow you to modify them or mint them. In this case, Alice wants to do a purchase of token X. So she's calling the transaction that says create, and then she transfers it to herself. So from the moment that she transfers the transaction to herself, it's under her account. There's nothing, the smart contract has no idea if Alice has or not the token X. And she's allowed to do everything that it wants with it, and no one else has that possibility. So on Sui, the smart contract, because it does not have any state, cannot actually affect the object without the user's consent. So the user will have to actually agree to any transaction, whether it's and usually if it's not beneficial, most probably the user won't want to do it. So if Alice wants to transfer the token to Bob, she's the only one. She needs to sign the transaction. If she doesn't sign it, that won't happen. Even if the contract sent the token by mistake, then it's tough luck. So yeah, so she transferred it, and now Bob's on the object, the token, and now Bob is deciding what will happen with the token. Alice has no more say in it since she's not the owner. And this is how it goes with Sui. So in Sui we have objects, and we have 4 types of objects. There's owned, shared, frozen, and immutable. The owned objects are the ones that I showed previously. Owned objects, if you own them, you own them. And you have to sign the transaction that actually mutates them or changes them. Shared objects are on the opposite spectrum, because in order to have basically to have some logic on like a marketplace or something on the blockchain, you would need somewhere that many people have access to, and this is a shared object. So you're allowed to input the shared object in a transaction as an argument, and there will be no check to the owner. And when it's an own, there will be a check. If the signer is the owner, the transaction will pass. If the signer is not the owner, the transaction won't pass. The frozen items are read-only, so you're not allowed to mutate them anymore. So you can have an owned object, and for some reason you might want to freeze it. Maybe it has some config that you want to remain that forever. And immutable objects are the same thing as a frozen, but it happens later in the life cycle of the object, and immutable is from the get-go. 99% immutable objects are packages. So even packages, which is the smart contract itself, it's an object for Sui. And they are immutable, which means that you cannot alter them after you publish them. But you can upgrade them, and we can talk about it. So on Sui, own objects are, you can be anything. It can be game assets, it can be coins, real world assets. We have even capabilities, so you can do token gating capability. If you own that object, you're allowed to do that transaction. You're allowed to do this change on the chain. If you don't own it, then you can do it. So yeah, you can be gating tokens as well in general. Scam tokens as well, we have quite a few of them. And the question is just who is the owner. So every time there will be a check, do you own, you're trying to change, you're trying to send 10 Sui to someone. Do you own that 10 Sui? If you don't own them, you cannot do it. Shared object though. So owned objects, so the owners can be an address, which means a person, actually a user owns them. It can be another object, so you can transfer it to an object and have some logic on how it can be retrieved. We have the idea of a dynamic field, which means that an object can have a new additional field, so that can own objects. and you can wrap them inside an object. And it will be clear later, so owning it. So here the object, I use the same address because every object has an ID on chain, and it looks quite similar to an address. It's exactly the same. So if you don't check, you actually won't know if it's an address or an object. And you can send it directly, or you can have logic that actually a field of the object, some data of the object is actually another object. You can have an avatar that has a sword, and that we call them like wrap. So here's how the state of Sui goes. This is at some point in time, this would be the state. So the state is only tracking objects. So here we have a coin of Sui, and it has some data, it has a value, it has the owner and some other perhaps metadata. And here we have a copy. This is an NFT that's quite popular on Sui. It has its own values like height, color, background, and an owner, which is an address. And we have a marketplace that has its own values, usually it's other items, and an owner, this is shelf, so anyone has access to it. So this is the state at this point in time. And here I have two arrows, but it's one transaction, so a transaction happens that touches two objects. So after the transaction happens, the transaction is actually Alice wants to put her NFT for sale on the marketplace. So she calls the transaction, she inputs the owned object and the shelf object as an argument, and then a change happens so again we only track the objects, a change happens, so the copy, now the owner is the marketplace, and in the value, so you have the copy, the NFT as well. So for both, nothing changed here, because the transaction didn't affect him, and actually, so for this coin, nothing changed. And the big difference between owned and shared object is that this transaction, because it involves a shared object, it will go through consensus. If there's a transaction that doesn't involve a shared object, it doesn't go through consensus. So we have a lot of transactions, and mainly 70% of them, that do not go through consensus. In the next change of state, we have Bob that wants to buy the NFT, so he calls the transaction that it's called buy NFT, he inputs the coin, he specifies the ID of the NFT that they want to buy. And here what happens is that, okay, now the NFT, the owner again changed, the market lost the NFT, but a new object appeared. So the value, the big part of it went to Alice as the seller, but there is a fee that went to the marketplace. So we had a coin and it got split into two. So because everything is an NFT, on Sui even coins are NFTs. So you have like, if I have 12 Sui, I may have like a coin of 7 and a coin of 5. I can have a coin of 12. I can have any combination. Shared objects are the ones that go through consensus whenever the transaction involves them. Then they can be, usually if I pull the marketplace, but it can be a leaderboard, it can be a treasury where you want to store the profits. Kiosk is a feature of Sui that allows you to have royalties. You can have a registry where you want to register every transaction. That is a design decision, because if you're using a shared object, then you know that the transaction will go a bit slower. Transactions that do not go through consensus have 10 finality less than 1 second. Those that go through consensus have around 2 seconds until the user actually sees a change. The frozen and immutable objects, as I said, it can be a smart contract, but it can also be some metadata that you want to have there forever. Frozen and immutable objects cannot be deleted from the chain. All the other objects can be deleted. So, due to all this feature, because the object has the data inside of itself, also you can create a lifecycle with your object. So you define first the object, like what fields, what data you want to have it, maybe eyes and color and stuff like that. And then you decide how it gets created, a min function, how it gets destroyed, a burn function, and then a few functions that say how you can change them. Like it can be sold, it can be changed, the background, you can change the appearance, you can add items to it, and you can create a whole lifecycle. A case study is a very popular collection of NFTs on Sui. This collection is fully on-chain, so even the image itself, it gets generated because of the data that is in chain. There's nothing off-chain about it, and actually it gets displayed on the wallet, it gets displayed on the explorers, and on all the apps that are compliant with the display feature that Sui has. Even the accessories themselves that you can add to them are, again, everything on-chain. So this doesn't need a Web2 backend like a database to store any information. Consensus? Yeah, consensus. This is my feeling about consensus. It goes pretty fast. It's in the worst case scenario, it's around 3 seconds until a person actually realizes that it sees the result of the transaction. The actual transaction, the actual title finality, the validators that they need, it's less than 0.5 seconds. But because we have the full node to validator and validator to full node, it gets the additional time that you need in order to see it. The white paper is pretty involved, so I didn't add it over here. You can go and read it, and then we can discuss it if you want. Soon we'll launch the new version, and they promise that it will be like 20% faster even. So, features of Sui that makes Sui unique. ZK login, I will talk it about on the next slide. We have on-chain randomness, so you have randomness natively on-chain. You can request a random generator that can give you as many random numbers as you want in every transaction. We have multisig natively on-chain. You can define multisig schemes where you can have one address that, 1 out of 2, so you need one address at least to sign the transaction, or you can have 2 out of 5, 2 addresses need to sign a transaction. You can even put weights and say one address, if it signs the transactions, it goes through. If it's any other address within the scheme, you need a list tree. We offer, so addresses are based on 3 cryptographic schemes. It's the one that is used most generally, the SCCP-256K1. But we also allow the EDDSA and the EDCSA, but the R1. Dbook, this is a reason why DeFi protocols love Sui. Dbook is a fully on-chain central limit order book, so you can have an order book on-chain, and it's the next step after AMMs. SuiNS is a domain name that we offer. You can, instead of addresses, you can have an @Alex, @mybusiness, @whatever, and that gets translated to an address. You can have SuiNS for your objects, and very soon you can have a domain name for your packages as well. So instead of other users to search your package by address, they can just do an @marketplace.com. Display allows you to show visually any asset that you own on explorers and on wallets. Kiosk is mainly for royalties. Walrus, as I talked about, is decentralized S3, is a decentralized storage of data, and it's because it's made by Mr. Labs, it's fully compatible with Sui, and you can use it in order for your application. And PTBs, I will talk about as well, is programmable transaction blocks. So ZK login is a thing that I thought it was more prevalent, but I realized that very few chains have something like this. On Sui, you can create an address from an email. So if you have a use case where you want to address to Web2 users, you can allow them to log in by Google, and we offer Facebook and many more providers with OAuth, and they automatically get a new address. And this changes a bit the logic, how it's made, because the address here is the thing that never changed, but the keys are ephemeral and they only last for one session. But the user does not know anything, and he doesn't have to know that he is using a blockchain. And over here with ZK login, they need to log in, but you can skip from them having like a pop-up every time, do you accept this transaction, do you accept this transaction? And it's a very neat way of making the user experience be more seamless. So programmable transactions, one of the most notable things that we have and is lacking in general in the blockchain ecosystem is that you can make many transactions into one. And what I'm saying about that is that you can, for example, for DeFi, you can do a swap through many pools in one transaction, and you don't need any code on chain. So in other blockchains, you would need to write your own smart contract that does all this. On Sui, you can just say, I want to call this transaction that says swap pool 1. I will get whenever I swap my coin, I will get a new coin. Take that result, put it in swap pool number 2 in order to get the next coin. Take that result, put it in the next swap pool in order to get the next coin. And finally, when I get the coin that I want through the route that I decided, transfer it to myself. And this gets made into one transaction, and then the validators execute all of these in one step. If any one of them fails, then the transaction fails. And if it succeeds, it's considered one transaction and you pay the gas for one transaction. The same with an NFT, so this is applicable in many so it's actually a feature that everyone uses it because it's so handy. You can create an NFT, you can immediately change the color of the NFT, then you can add an item to the NFT. You can create an item in the same transaction and then take the NFT and the item and then add the one to the other and then put it for sale, and that can happen all in one transaction. So yeah, the aim for Sui is to be the coordination layer for intelligence assets, where you have all the data on chain, you have a life cycle for your assets, and you can allow your users to come either from Web 2 or Web 3 or any other. I won't go too deep into Move. There is a Move book, but the general idea of Move is pretty much like an object-oriented language, where you have a class. In this case, we name it struct. So you have to define a struct. You have to say what type of fields it will have. The ID makes it an object on chain, which you will be able to choose if it's going to be owned or shared. And then it has all the other data. It can have buys. It can have. So in this case, I'm trying to make this copy, so which is just an NFT. So I have to define all their eyes, mouth color, and stuff like that, like primary and secondary color. For the accessories, I didn't write them over here because I mentioned dynamic fields. Even if you created this and you publish the contract on chain, which means that you cannot change it anymore, then you can add new fields dynamically, and you can say, I want to add items to my NFT, and you can add them as a dynamic field over here, and even the display object the display standard can work with it and show your items. So the big idea is that you define your structs, which will be your assets in general, and then you start writing functions about the logic, and that's all that there is to it. So I have this asset, what I want to happen to it, I want to be able to mint it, I have to write a mint function. Do I want to be able to burn it? I would have to write a burn function. Do I want to be able to change any of this data? I would have to write a function and define the logic that changes the data of the asset. And when I'm done, then the contract is done. Because the contract does not keep any state, there's nothing else that you actually have to do. So yeah, these are the two steps. You just define your asset, how will they look, and then you implement the logic that you want them to have. And Move is very safe, so if you do all this and it compiles, most probably you won't have any problems, any hack issues. The only issue that you may have is if your logic is a bit flawed and you have allowed access to some functions that you didn't want. And that's the only thing that you will have to look for. Everyone, so an anecdote here. In the 1 year ago when we first started Sui, I was supporting partners, and we had a partner that decided to come onto Sui, but the developer was not really convinced, like, why did we go to Sui? He was a maxi of another chain, if I may use that word, and he still loves that chain very much. And after 1 week, when we showed him Move, we showed him how he will be able to do what he needs to do, he was saying, oh my god, Move is so good, Sui is so great. Like, I'm on the other chain, I'm in the forums of the other chain, and they have like, oh, I wish that this chain could do that, maybe you can. They were like requests for implementation for the chain. And he was saying to me, I'm thinking, oh, Sui already has it. And then there's another request like, oh, I wish this chain would have that, and I'm thinking Sui already has it, and I like this a lot. And I'm going to meet this person for the first time over here. So yeah, getting started, and this would be your task for everyone that wants to complete the workshop, is install Sui. This is not trivial, it's fairly easy if you have a Mac. If you have Windows, you